By the way, we're very honored to have Jason Nichols here, the CEO of Startup OS and the former director of AI at Walmart, the largest company in the history of the human race.
Thanks, man. I'm really glad to be here. Honestly, I'm honored to be here. So thank you.
Thank you. Brilliant technical mind. Oh, and let me post the slide deck in the chat. Okay, cool. I'm going to get started. So just a real quick short introduction to our host, which happens to be us this week, which is Tori. So we're the world's first and fastest growing AI sales platform for hotels. We use generative AI to automate a lot of the manual human guided sales processes for hotels. So tasks that would normally take an hour or more, we can complete in 5 to 10 minutes. Yep. And I just want to put a shout out up front that if anyone's interested in investment opportunities or internship opportunities, definitely reach out to me directly or Jason, the CEO, directly. He's at a conference today, so can join us. And we'd be very happy to speak with you. So today's presentation is from me. It's on self-RAG. Similar in theme to the presentation last week on corrective RAG. So the paper is called Self-RAG, Learning to Retrieve, Generate, and Critique Through Self-Reflection. And there's the paper here. And what I think makes this useful as well is they already have a code base. So they have a pre-trained model. They have code to retrain the model on your own data. Not just theoretical. And the key finding of the paper is that key approach is that they introduce these new special tokens called reflection tokens. And the reflection tokens work such that in contrast to traditional RAG, I'll go over that for anyone not familiar in a moment, but in contrast to traditional RAG, where after every, say, sentence or maybe only one time throughout the generation process, data is retrieved to augment, to provide supporting information for the current generation of the model. This paper does a more dynamic retrieval in which a special token is generated that guides the model on when to retrieve. So just as a traditional language model would have a softmax at the end for each one of the many tokens in its vocabulary for each, this has a special token just for a reflection tokens, kind of indicating that what's being generated requires supporting evidence. Yeah, so self-RAG, as I mentioned, uses these retrieval tokens. An interesting takeaway for me from the paper, which is very obvious in retrospect, is that separate models can be used for retrieval and generation. When you go through each of the points in your data set and vectorize it, one model can be, say, Gemini for retrieval, and one model can be generation. And that kind of means that you can fine tune on just retrieval as opposed to both retrieval and generation together. And I'll zoom into more detail in just a moment on how self-RAG works. So in traditional RAG, as I mentioned, the model takes in a prompt as usual. Say, in this case, it's how did US states get their names? And what happens is, this sentence is embedded with, say, clip or uh, OpenAI's embedding model. And so is each of the segments of your data set that contain supporting evidence are also vectorized using the same embedding space. So here, each of these sentences are in the embedding space, and through a nearest neighbors model, you'll find that these three sentences out of your entire corpus are pulled back by your retrieval process. And then when you ask the model to generate after it's given this prompt, it takes all the three sentences and the prompt and then uses them together to generate the output. Here, they're kind of intentionally trying to diminish RAG because they are supplying their paper as the improvement over RAG. So here they're intentionally showing an example where RAG isn't working well. So they're saying it's named after Christopher Columbus, and I guess supposedly that's because not all the retrieved documents are very relevant to the prompt. So yeah, so the downsides, as I just mentioned, are that there's a fixed number of documents for every generation, regardless of whether it's necessary or not. It doesn't take into account whether each of the retrieved documents is useful or not as well. So you could be overwhelming the generation model with irrelevant data, or maybe it would have done well without the retrieval. So self-RAG is the paper's improvement over RAG. And as I mentioned, you put in this prompt. So it would say, US states got their names from a variety of sources. And then it does start the generation process. And then the first token out of the generation now is this retrieve token, just like any other token in the vocabulary, except, the code, as you would see in the GitHub repo, then encounters this retrieve token. And instead of immediately, generating the next token, it would begin this self-RAG process. So it grabs three different retrieved documents, just as you would in RAG, except now it's also performing, it's also generating these other special tokens, indicating whether the document that was retrieved is relevant or supported. So here you see this 11 to 50 state names comes from person, so that's relevant and supported. You see in the second prompt, it's considered irrelevant to the prompt question. And then this one is relevant and partially supported. And then it's kind of engaging in a beam search here. So it now generates a new output in parallel for each of these different prompts, for each of these different reference documents, and then produces a full next segment. And they define a segment as a full sentence. So basically, until the next sentence ends, it keeps generating and then selects the best segment that fits the goal of the prompt. Yep. And then here they're actually showing a different use case for self-RAG. So on the top, you're asking a very factual based question. So you ask US states got their names from a variety of sources, or how did the US states get their names? And the generative model will either provide a factual answer or a non-factual answer. So, in business use cases, that can be very important, right? There's that situation where that one airline was giving false information, and I think it was shown in court that the company is now liable for the false information that the AI presented to the public, to the customers. So there are cases where preventing hallucinations and presenting factual information is very, very important. On the bottom is this different case where you're asking the AI model not to present factual information, but just to be really creative, right? Have a high temperature in its generation. So when you say write an essay of your best summer vacation, you don't want it to just give a biography of the AI's experience on a summer vacation. You want it to be very creative, and that means not using any reference documents and just kind of, doing standard autocomplete here. Yep. Any comments or questions so far?
Are those tokens, or is that binary classification for relevant, irrelevant, and supported, unsupported?
Yeah, my understanding was that those are their own tokens.
Interesting.
Yeah. Um, if anyone has their paper up, yeah, on page 4, they have the algorithm, and we'll get to training as well in a moment. Yeah, also on page 6, the tree decoding with critique tokens. These are the critique tokens. Yeah, so self-reg seeks a balance between being creative when more randomness and creativity is desired, and being factually based when providing truthfulness and support is required. Yeah, and here are those special tokens that Jason was just asking about. So you have the retrieve token, and I think they can come in different, I guess, flavors. So retrieve yes, retrieve no, continue, is relevant, is it irrelevant? Is this document that was just generated fully supported, partially supported, no support? I actually did have this exact thought about, are these tokens or is it classification? And I think a thought I had yesterday as I was reviewing this paper again is that, does it actually matter? Because you're using the base, the base model weights. It may be, if you were doing classification, you would just have a different output layer, right? So it may be more of a semantic definition than um uh technical practical definition. Yep. So the way training operates, and this is on their GitHub repo, is that they generate the critic training data with GPT-4, and we'll get into that in just a moment. And then they train on that critic data, and then they generate they create the data for the generator, which is actually generating these tokens, and then train on the generator. Pretty standard pipeline here of work. So the critic model takes a prompt like this. So given an instruction, please make a judgment on whether finding some external documents from the web helps to generate a better response. So this is essentially, as I'm understanding it, just knowledge distillation. So running ChatGPT for a proprietary model can be expensive. They wanted to save money, as I'm sure we all do. So rather than running ChatGPT 4 each time to determine whether retrieval is necessary after a sentence or for a sentence, they would just ask ChatGPT during this critic training phase. And then once they have their model that can pretty accurately predict whether ChatGPT would require retrieval or not, then they have their own model that they don't have to pay as much for. But I think this piece actually kind of makes the paper a bit more complicated when you first read it than it actually is. So I took a whole bunch of notes just for myself here, kind of on how the training process worked and what kind of data sets they used. So this is for the generator model. I think they use some of these 150,000 examples of input-output pairs. They use this benchmark for knowledge tasks. This ASQA paper has some examples as this other data set they used for their experiments and training. Yeah, so then the generator model is trained in a very straightforward manner. They just train to optimize standard next token objective, right? And then whether the reflection token exists or not, so they start with this initial data set, and then they go back and run this predict model over it. So after each sentence, they'll say, of the ground truth data, they'll say, did ChatGPT think there should be should there be supporting documents provided after the sentence? And then they'll use that to insert these reflection tokens back into this original data set. And that's their the data set they use going forward. And then just, yeah, for loss calculation, they mask out the retrieved tech chunks. So, you know, the supporting documents are masked out for when they calculate loss, which makes sense because that's not part of the decision making of the generator itself, is the supporting documents. And yeah, I'm not familiar with this model of contriver MS Marco, but that was mentioned as part of the retrieval process. And they selected using 10 documents as the hyperparameter for how many documents to retrieve each time they perform a generation. So yeah, I mentioned beam search before. That's just a way to kind of limit the search space for graph-based search. So in this case, you know, they start with the retrieval and they start generating, and rather than just pick, say, the top one best token each time, they say would look at the top 2 or top 3 next tokens that can be generated and kind of continue on until the sentence is completed. And then now that the whole sentence is completed, they take the best result. So you know, that kind of strikes the balance between only looking at taking the, you know, best token at each time together to create a best sentence and searching all possible, you know, tokens, which would be an exponential level problem. So yeah, they performed these experiments on closed set tasks. So this seems very straightforward. This one, multiple choice questions. They mentioned these challenge tasks, and I wasn't too familiar with what that represents. Short form generation. This I'm also a little unclear on. I don't know if anyone else on the call is more familiar with good metrics for these types of tasks. Because you know, traditionally a big problem is that it requires a lot of human judgment, which of course can be very costly because you require you know, humans to spend their time working on it. And they also mentioned this long form generation task, and that used this metric fact score, but I didn't have the time to look into what metric fact score, how that's calculated, but I do believe there's a paper on it.
Julian, on page 6, challenge tasks is a subset of closed set tasks. It's the arc challenge. It's bolded. It looks like it's another bullet point. But
Yes.
I'm looking at the paper, 67. It's not actually.
Yeah, you're absolutely right. Okay, that makes more sense.
Yeah, you got it. It wasn't a separate set.
Yeah, thank you.
No worries.
Cool. Yeah, so then their experiments, they compared without retrieval, which is a little bit of an unfair comparison. But they compare against Llama 2, Alpaca, ChatGPT, Llama 2 Chat, chain of verification, and then they compare it with retrieval, which is its own slide here. And they compare it against, yeah, standard RAG. So that's some of these same models: Llama 2, Alpaca 2, Llama 2 fine-tuned. This one seems more fair. It was fine-tuned on the same training data that they trained self-RAG with. but without the reflection tokens or retrieved passages. This RET chat GPT model and Ret Llama 2 chat were trained on private data, and they also compared it against Perplexity AI. And they also compared it against these concurrent papers. So Sail, instruction tuned on Alpaca, instruction tuning with top retrieved documents inserted before instructions, and Toolformer. Cool. And then these were the results. These scores here I indicated kind of indicate the factuality metric. But yeah, this would be a great area of further investigation, how fact score works, how reliable is this metric. Yep. So you see it performs really well on pretty much all of them, all these metrics. Still 55%, not super high accuracy. Yeah, so these graphs kind of indicate how much training data helps. That's always a painful question, I think, to answer, is how much training data do you need? Cool. Yeah, so just final thoughts are that clearly, this can help save. So in my mind, what this paper solves is the issue of having the generative model, say in like LangChain, answer a full prompt after each sentence of whether or not RAG should be required. So yeah, I feel like my personal thought is, you can do this kind of manually at the moment, just with a LangChain. You produce one sentence of output, you ask the model to reflect back on what you just generated, or ask it just as they were asking ChatGPT for the critic model. Would it be helpful to provide supporting evidence or supporting documents? Get those documents, ask it again concurrently. Would it benefit, is this relevant or not to the prompt? And then just kind of manually run self-rag like that. But I can see this of course saving money because you're not running inference as much. You're definitely, performing inference faster. But I'm sure this technique and similar techniques might be used well in the future. But still kind of up in the air as to whether it's something people immediately want to act on. Cool. Questions and comments?
It's a great paper, man. Thank you.
Yeah.
This is really awesome.
Anyone who attended last week have any comparisons on corrective reg? Very silent group today, but yeah, I appreciate everyone attending.
Yeah, thank you. I thought this was a very good presentation of the paper and kind of the strength and weaknesses there. So yeah, I appreciate that.
Yeah, I think there was initially some concern that it wouldn't be very applicable because it was very theoretical. But yeah, like I mentioned, the whole code base exists. It's actually quite detailed, and they give a lot of documentation as well. So it might actually be worth giving a try if relevant to people. Yep. So yeah, just want to give a call out to some future speakers that we have on our calendar. So Red is speaking next week on Red. You want to just give a quick explanation?
Yep, sorry, took me a second to unmute there. Yeah, so it's basically going to be going over a paper about generating music with an LLM and training it from scratch, and the data representation involved in getting it to generate multiple instruments at the same time. So yeah, hopefully it'll be interesting and engaging because yeah, it's going all the way from like raw data set to actual kind of UI type thing. So yeah, excited to present next week.
Cool. And my understanding is that you'll have a cool practical like demonstration of actually, you know, walking through training code and some best practices for AI model development, right?
Yeah, so this is going to be, I guess, an LLM, you know, that's just trained from scratch, pre-trained from scratch. It's going to be like small enough that you can train it on your machine. The use case isn't going to be immediately applicable to almost anyone unless you're currently, you know, trying to compose music with an LLM. But I think the idea is to just go over some of the insights and some of the kind of I guess I don't know, reasons why this approach, you know, was taken over others, and the advantages compared to, you know, some other ways of doing it, and how you can potentially think about that with your own problems.
Yeah. Excellent. And then yeah, the week after we have Wyatt and then Peter Turlicki. So yeah, thanks everyone for attending. I'll ask one more time if anyone has any more comments or if anyone wants to put out that they're recruiting or cool. Yeah, thank you so much for attending and have an amazing week, everyone.
Thank you.
Cool.
Thanks, Julian.
Yeah.
Thanks. Bye-bye.